Mrs. Howard's chemistry class, Unit 10, Heat and Thermochemistry, and this is Part 5. Part 5 is going to be dealing with heat transfer. This is stuff that you guys should already know, so this should be a reminder of information that you already have implanted firmly in your brain. Remember conduction, convection, and radiation? How is heat transferred from one thing to another? First type of heat transfer is called conduction. And conduction is heat transfer through direct contact. You have to be touching. So if you reach out, you remember if you've been around little bitty kids, every once in a while they'll reach out to touch something hot and you have to smack their hand and say no because you want to keep them safe. Because there can be so much heat transferred through direct contact, it can actually damage the skin. So conduction is heat transferred through direct contact. The energy moves from one place to another, but the molecules don't. So you reach out and you grab the handle of that hot pan or that hot spoon, and you don't have metal molecules jumping into your skin. You have the energy from the metal handle going into your skin and giving it so much energy that it actually burns it. So if you look on the picture down below there, you see the hand of the guy reaching out and touching the handle, and that's conduction, direct contact. We talk about things conducting electricity too. Conduction refers to something where you have a constant line, it's unbroken. You've got a constant contact or a constant unbroken line for electricity or heat to transfer through. Okay, conductors then are materials that can transfer the heat really well. So if it's a good conductor, it's things, they don't keep the heat inside. They can pass that heat on along to something else. Metals are fantastic conductors. You guys already know this. Materials that don't conduct heat very well are called insulators. So usually when we say conductors, we're not simply talking about heat. We also kind of include electricity in there. Also, in insulators, same thing. If they don't conduct heat and electricity very well, we say they're insulators. Styrofoam, great insulator. Plastic, great insulator. Liquids and gases and porous materials are usually good insulators. If you have something that has a lot of air in it, then it's not easy to transfer the heat through the air, so they're good insulators. A lot of your thermos cups or your insulated cups, they'll have a layer of plastic and then a gap and then another layer of plastic. So there's nothing in between, or they'll put some air or something in between those layers, but there won't be a solid for the heat to be transferred through. Alright, here is another of the tax questions. You can guarantee that they're going to ask you a conduction question on the tax test. If it's the following year and we're taking the STAR test, the EOC chemistry test, more than likely, since they were so happy with conduction, convection, and radiation with the tax test, they're still going to be happy with it now. So we have temperatures of water in different containers. Container P and Q. The initial temperature for both of them was 90 degrees, and then the final temperature, P was 83 degrees, and Q was 76 degrees. Which one lost more heat? Well, Q lost more heat, so apparently Q is not as good an insulator. It's a better conductor than it is an insulator. So let's look at the question. Container P and container Q each were filled with 0.5 liters of water. The water was heated to 90 degrees Celsius. The table shows the temp after both containers were allowed to cool for 3 minutes. Compared to container Q, container P is, alright, container P, is it a better insulator? So we're looking at in terms of container P. So container P, is it a better insulator? It kept the heat in, or is it a better conductor? It let the heat out. Well, it kept the heat in. It kept most of its degrees of temperature, so it's a better insulator. Here that we have it. Capital letter B, convection. Convection is the second type of heat transfer, and convection is heat transfer through currents. Like you've got to have the whole material able to move around. Well, it's kind of difficult. If you have a big chunk of a rock, it's kind of difficult for that rock to move its molecules from one side to another. It doesn't work that way. That's not the definition of a solid. It's going to maintain its shape. However, when you have liquids and gases, those particles can move around inside there, right? I can take my Dr. Pepper and shake it around, and it can move around in there. So you have a current that can form. So convection is the transfer of heat energy through currents in a fluid. The molecules are in motion. So conduction, the molecules weren't moving from one place to another. You were just transferring the heat along. Convection, the molecules themselves are moving along too. If you look in the pretty picture down on the bottom, you see the little black arrows kind of up and down in the pan, the liquid stuff inside the pan, because the liquid can start moving around inside there, and that's how you're transferring the heat around. Convection occurs in all fluids, liquid or gas. That word fluid refers to matter that can move around, can flow, and so liquids can flow, but also gases can flow. As the fluid warms, it becomes less dense and it rises to the surface. Once it rises to the surface, and if you're looking at the pan down there, notice the heat's on the bottom of the pan. Once it rises to the surface, it gets cooler. It's farther away from the heat, so the cooler stuff sinks back down, and then you get this little flow, this little current moving around like this. Alright, so next one. The primary way liquids and gases transmit heat is by the process of convection. We just said that. Conduction, convection, radiation. Those are your three options there. Conduction's got to be through direct contact. You've got to touch. Radiation, we haven't talked about yet. And then convection, you have the fluids, gases and liquids. They're always going to be talking about gases and liquids when they talk about convection. Okay, last type is radiation. And radiation is heat transfer through the electromagnetic spectrum. Right? Electromagnetic spectrum, we talked about that earlier on in the school year. We talked about microwaves, X-rays, gamma rays, visible light, infrared waves. We talked about those. All right, we're going to go and make a chart here. It's on your notes page, and we're going to go from the longest wavelength with the least amount of energy to the shortest wavelength with the most amount of energy. So radio waves, microwaves, infrared waves. That's where we can start feeling it. You know, you've got all these radio stations around the world here. You've got radio waves smacking into you all the time. Microwaves you've got moving in and out of you all the time. Infrared waves, yeah, that's heat. We talk about those night vision goggles. Most of them work based on infrared waves. So you've got heat coming off of everything, and those waves are going into your body. Visible light, obviously, if you can see, you've got light waves going through you too. Ultraviolet rays or waves, X-rays, gamma rays. All right. Now, I say they're going through you, but they really have to have a certain amount of energy before they can actually make it through your body. So look at the real high energy stuff. Gamma rays, they have so much energy, they can zip right through your body and they can cause damage when they go through. Those are the ones that can cause cancer, radiation poisoning, cancer. X-rays, too much of those, they can zip right through your cells. They have a harder time going through the bone tissue, right? That's why we can use them. They go through the soft tissue of your body, but they get stuck with the bone or the hard tissue. And then you have ultraviolet radiation, and you know it can cause enough, it can get through the outer layer of dead cell tissue, but put a little color in it, the little color to your skin, the melanin, and it stops it there. So it can cause some damage to your skin there. If you've ever had a sunburn, yeah, you know it's got enough energy in those UV rays that they can cause some damage to your skin. Heat radiation, what we're talking about, a radiant heat or heat radiation, is usually referring to that infrared wave we're talking about here. All right, here we have a beautiful picture showing the electromagnetic spectrum going from right at the longest to left at the shortest wavelength. And it's just running through here and saying, hey, let's look how long the waves are. So radio waves are really long, low energy waves, all the way up to, ooh, look at those gamma rays, shorter waves or rays, and they're much more higher in energy there. All right. So, an example would be popcorn that's popped in the microwave. That's an example of radiant energy. All right, on your next tax question, heat convection occurs in gases and liquids, if I can read. Heat convection does not occur in solids, because, you know, in order for convection to occur, it's got to have those molecules that can flow, because solids are unable to flow. So, letter A, they absorb heat by vibrating. Letter B, they transfer heat by fluid motion. Letter E, they emit radiation by reflecting light. Letter D, they exchange heat by direct contact. So let's read the question again. Heat convection does not occur in solids because solids are unable to, does it say anything about flowing or it's being fluid? Look at letter B. Solids are unable to transfer heat by fluid. Solids aren't fluid. Solids are the opposite of fluid, which is solid. Again, you have a picture down below here, and we have examples that's pointing out the conduction, the convection, and look at the light coming off of the flame. If you put your hand near the flame but not on it, you can feel the heat coming off. That's radiation. All right, a solar panel or a solar heater uses energy from the sun to heat water. The heater's panel is painted black. Why is it painted black? If you vaguely remember earlier on the school year, we talked about the fact that if you wear a white t-shirt, it absorbs it reflects all the light. If you wear a dark t-shirt in the summer, it's going to absorb all the light. So the heater's panel is painted black to improve emission. No, the panel's not emitting radiation. It's going to suck it in, right? The heater's panel is painted black to reduce the heat loss by convection. No, not by convection. The panels aren't liquid. The heater's panel is painted black to improve absorption of infrared radiation. There you go. You want to paint it black to absorb more energy. Absorb more infrared radiation, that's a type of energy. So letter H, we paint it black so it absorbs more energy. It's going to absorb all the colors that you think red, orange, yellow, green, blue, indigo, and violet. It's going to absorb all those, so it's taking in more energy. So that means you're going to be able to convert more of that energy into a usable form of energy rather than just light or radiant energy. All right, conduction, convection, radiation, and here you have something, picture, and this one really has to do more so with weather. So you have radiant energy from the sun, and it's going to heat, it's going to shine down on that pavement. You guys have all been out on the street in the summertime, and you've felt that pavement. It's really, really hot, and the pavement warms the air right above it, and the warm air gets less dense. It spreads out, and it rises up, and as it gets farther away from the hot pavement, it cools off, and then it sinks back down, and so you've got that flow. That's also what really we have just a primo area around here set up, so at certain times of the year we make really great tornadoes because of this process of convection there and radiation. Conduction, not so much, but convection and radiation really have a big effect on the weather. That's really what runs the weather pattern. All of these three, conduction, convection, radiation, you can guarantee will be on your tax test, and more than likely on the STAR end of course exam for chemistry also.